30 of July.
Okay, sir. Shall I start?
Hello.
Hello. Sir, good morning,
Hello.
sir.
Good morning, sir.
Sir, are we wait for 5 minutes, sir?
Yeah.
The participants, they are coming, huh?
Okay, sir. Sure.
Okay, sir. Please.
For joining and leaving.
Somebody. Yes.
One day you could have started.
After 58.
As you said, if you want to wait
Because
for
our like
After starting program, we can admit.
we can continue, we can keep on
Uh,
while we keep on
keep on going.
okay, right.
Pop-up sound. Admin जो आ रहा है ना बार बार पॉपअप हो रहा है इसका साउंड उसको
Microphone. Thank you, dear.
system
So first I'll tell it will not look
Hello.
Yeah, I'm admitting.
Hello, sir. Hello.
Hello.
Hello, sir.
Sir, சொல்லுங்க.
Hello.
Hello, please tell me,
Shall
sir,
we
please.
start? Shall we start?
Yeah, we'll start, sir.
Okay, sir. Okay. Camera.
Shall I start?
Switch on the camera. Switch on.
It's on, sir.
On.
Camera is on.
Wait, not coming in.
It's on.
Not coming in. Wait. She has to click on it.
Yeah, it's
On her PC. Okay, start. आपका भी admit करो. You leave it. You start. They're visible for me. No problem. You do it. Don't do it. Don't. You start.
Good morning, one and all. I am Athiya Sultana, Assistant Professor, Department of Electronics and Communication Engineering. On behalf of Navodaya Institute of Technology, Raichur,
Who is coming?
I welcome you all to this webinar. Now I request our HOD, Dr. K. Venkatachalam sir, to introduce our today's resource person and give welcome address.
Respected principal, vice principal, beloved my friend, associate professor, Dr. S. Anand, Department of Communication Engineering, School of Electronics Engineering, Vellore Institute of Technology, Tamil Nadu. Dear faculties, professors from various institutions, dear students from other institutions, very good morning to everyone. On behalf of AC Department, Navodaya Institute of Technology, Raichur, I would like to welcome all of you for this grateful webinar of an one-day national webinar on sensors and sensing technology for structural health monitoring. I take this opportunity. I am happy to introduce our guest, Professor Anand, for this webinar. Professor Anand has completed BE in Electronics and Communication Engineering from Anna University, Chennai in the year of 2007. Later on, he pursued his MBA E-Business from Annamalai University, Chidambaram in the year of 2009. and he has completed M.Tech Nanotechnology from Nurul Islam Center for Higher Education, Nagoil, Tamil Nadu in the year of 2011. He has completed PhD from National Institute of Technology, Tiruchirappalli in the year of 2015. He has more than 10 years of teaching and research experience in various institutions. 3 times he has received Best Research Award from VIT in the year of 2016, 2017 and 2018. He published 11 research articles in SCI and Scopus indexed journals. He got Best Paper OSA Award from IIT Kharagpur in the year of 2014. And he presented his paper in 14 national international conferences at NITs, IITs, IISCs, and abroad. Once again, I welcome all of you for this webinar. Thank you.
Now I request our Vice Principal, Sir Dr. Suman Kumar, to give special address.
Yeah. A very good morning to today's speaker, Dr. Anand Srikantan Thampe from VIT. Welcome you, sir, for this one-day webinar on sensors and sensing technology for structural health monitoring. Welcome to all the participants, the students, the faculty from NIT and different colleges. You're most welcome to attend the webinar on sensors and sensing technology for structural health monitoring. The learning should never stop, whether it's a pandemic or anything else. As a part of internal quality assurance cell, we have our event calendar where we have got our scheduled seminars and guest lectures for our students and the faculty. And as I said, whether it's a pandemic, the learning should never stop. And this pandemic has definitely taught us one very important thing, that the importance of the sensor-based health monitoring system. Since Corona being untouchable kind of a disease where you cannot directly contact with the person, you need something which can be done from away, right? So I felt like this topic is quite suitable for this pandemic, where you all can discuss and come on a common discussion for a development of such a device which could be helpful in such kind of a pandemics in future. I appreciate the effort put by the Department of ECE, Dr. Venkatachalam and their team for taking out such a topic. And I, wish you all, the participants, to take away something from this webinar. Thank you.
Now I request our today's resource person, Dr. Anand sir, to start the session.
Yes. Thank you. Is it audible, ma'am? Is it audible? Is it audible? Hello.
Oh.
Ma'am, is it audible?
This video will come.
Yes, sir, it is audible, sir.
Yeah, thank you. Thank you. Thanks for the response.
He is presenting.
Video.
Yeah.
Good morning to all. I'd like to thank Professor Suman Kumar.
This audio.
Shall I?
He is presenting this.
So shall I start, sir?
His voice is not on.
Hello, sir. Shall I start? Hello.
Hello.
Yeah, shall I start, sir?
Hello, sir.
Okay.
Hello.
Hello,
Professor
sir.
Anand, sir.
Yes, tell me, sir.
Hello.
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 Hello. Is it audible? Hello. Hello.
Video on. Hello.
It's not audible yet.
Hello.
Sir, it is
Yes, sir. Yes, sir.
Audible, right, sir?
Yes, sir. It is audible, sir. Audible, sir. You start, sir.
Thank you.
Okay.
Okay. One second. I like to thank Professor Suman Kumar, Vice Principal, sir. Then the Professor Venkadachalam, sir, and the coordinators team who put actually the maximum effort to conduct this event. And thank you all those who are attending, students as well as the fellow faculty friends. I'm sure this particular pandemic time, we are actually in front, we could see that the digital transformation in front. Digital transformation. In general, we used to comment our government of India aim is to make us a digital India, right? Digital India, but we have to proud of it. The thing is actually when they are actually promoting digital India, obviously the government of India will be sanctioning.
Excuse me, sir.
Sir, please, sir.
Your video not coming.
Videos. Oh, I have to on the. Okay, then I'll switch on the video also, sir. Because the
Yes, sir.
streaming, you should not feel the streaming problem. That's why I have switched off. Okay, now is it okay, sir?
Yes, sir.
It's coming, sir.
It's coming here, no, sir.
Wait, sir.
It's coming, sir. It's coming.
Okay, sir.
Okay, fine. Thank you.
Coming.
Okay, sorry for the inconvenience. I'm sure actually I cannot able to see myself here. Only I can see my screen here. Okay, so my hands will be here and there. I'll be moving. Okay. Here actually in general here very rainy. That's why I'm trying to use my mobile phone. Somewhat actually easy to get the signal. That's the reason. Okay. So when they are actually promoting a digital India, obviously the government of India sanctioning some 1,000+ crores to the digital India promotion, particularly towards, for example, developing the digital infrastructure. In previously, the normally University on a Grants Commission, UGC or AICTE, when we are sanctioning the department or when they are sanctioning the engineering institute or any kind of institute, right? Initially, they'll be demanding the physical infrastructure, particularly for the infrastructure building, what exactly the square feet you have, what exactly the land you have, such things normally demand. But in future, just see in front, we can see now exactly is nothing but whether you have the digital infrastructure. That's the beauty. That is the thing actually right now we need. So now my topic I have chosen today, sensors and sensing technology for structural health monitoring. Structural health monitoring, but in general, we are aware about the health monitoring. Health monitoring is nothing but the human body. We have to monitor the temperature, pressure, and with the help of other kind of sensors, easy to monitor throughout the body. But here, structural health monitoring. Why I have chosen this particular field, this particular structural health monitoring? In general, actually, this particular field is actually comes under civil engineering department. Civil engineering department. Sometimes I feel very actually guilty by when we are looking at the civil engineering department. It's very simple thing. The guy who is actually admitting in the civil engineering department as a student, when he is graduating at the end of the final year, right? He may not actually go through the very too many bridge courses or too many software tools or anything, nothing. Only because of his actually curriculum, he is getting a job or something. He is actually able to get a higher profile jobs, maybe in terms of government sector or maybe in terms of the construction sector or many designing aspects. Too many jobs opportunities today. But sometimes that's why I feel personally, I feel that way. The curriculum is actually framed the right way. Maybe that may be the reason. But for us, okay, our development is actually technologies. Each and day by day, our technology is actually growing very faster. That is the problem. When you are actually getting into actually engineering, maybe 2020 or 2018, when you're actually joining as an engineering student, when you're graduating 2021 or 2022, 23 or 24, right? That time, or actually particularly electronics and communication engineering, electrical and electronics engineering, slightly actually bit faster in technological, right? That is the reason. So how to, for example, for example, develop our skill, that is very easy, right? It's a very simple thing. It's nothing but just we have to track the recent magazines. So easy to understand what exactly on roadmap. Okay, fine. So here I have taken sensors and sensing technology for structural health monitoring. So throughout the session, I'll tell you what exactly my aim. My aim is very simple. I won't trouble you by inform by just by conveying the too many principles or theorems or too many expressions and all the things. I know that this particular pandemic is packed with many webinars, many things, right? So we are actually, I hope I have recently, just now I have inquired with Professor Venkadachalam sir. He said the majority are on UG students as well as the few faculties also, few percentage of faculties also. Okay, so here I have planned very perfectly, just only to convey the what exactly outside, what exactly the job opportunities outside. So how we have to focus towards this particular field. But this particular field application is nothing but towards the civil engineering aspect. Okay, so this particular session, without getting any visa, without getting any paying on an air flight, right? You will be going through across the globe, right? What are the some typical structures, how they are monitoring. Okay, right, many things they will be discussing about that. Fine. Myself, Anand Srikantan Tampi. Right now, I'm working as a associate professor in Department of Communication Engineering under School of Electronics Engineering, VIT Vellore campus. Fine. Okay, this is what slightly I'm getting into. For example, where exactly my focus here in this particular section, sensors and sensing technology is nothing but electronics and communication engineers and electrical and electronics engineers. Maybe IoT students also, maybe from information technology or computer science engineering students also, right? Because today's actually the front end is nothing but application based, mobile application based. So obviously we need their support. Even in our, if you know the Python or maybe in other application developers, right? That is easy to develop it, right? Interfacing also possible easily. Then structural health monitoring. What exactly structural health monitoring? Normal, some building, maybe bridges, or any maybe that's particularly in India. Actually, we are actually overpopulated. We should not comment overpopulated, right? Populated 130 crore on record, right? 130 crore plus. So this particular here, what exactly we need? The water resource is nothing but for us is a majority. We need the water. So water reservoirs we have dams, right? Throughout India, we have the dams. The main problem we have to monitor the dam property, whether the actual structural changes there or not. If it is collapsed, right? Just think that if it is collapsed, then what it will be? It will affect around some crores of people. They have to change their location. It may affect their lives, right? Many factors are there. So keep on, we have to watch the few structures, in particularly in India. So how to monitor it? It's very simple. Electronic sensors or electrical sensors. It's a very simple thing. So I have taken antenna and optical engineering. Okay, with the help of antenna and optical engineering, we could able to contribute, I think, few percentage for the structural health monitoring system. So particularly for antenna, I have taken radar devices, optical, fiber optic devices. Okay. Okay. After that, after getting the idea about radar or optical fiber sensors, right? Fiber optic sensors. Okay. What exactly my flow? Sure, I'm not going to explain in detail or the principle or mechanism of the sensors because we are aware about that. What exactly the humidity sensor? What exactly the fiber optic sensor? I'll be giving the idea. That's all. Okay. I won't trouble you in by explaining the what exactly the coherent control, the interferometric control and all that. I'll be giving the idea. Okay, this is what exactly the sensor we need. Okay, if we need this, but if you have this particular sensor, we can able to monitor these are the things. This is what my projection. Okay, so the basic mechanism and application. Then my focus, antenna and optical engineering based sensing technology for structural health monitoring. Okay. Okay. Now we are getting into our session. My session outline, structural health monitoring. Okay. SHM. Data acquisition system. Because when we are working with sensors, obviously we will be having the sensors, then followed by the output we have to maintain at the data acquisition system, then radar devices, fiber optic sensors, bridge SHM. This particular structural health monitoring specially designed for bridge to monitor the bridges. In for particularly in India, how to particular dam SHM. What exactly the water reservoirs? Structural health monitoring. Obviously, we have a lot of such a dispute we have across the states. But in particularly in Tamil India, right? We have the many across with many states, right? When you are sharing the water, or maybe when you're sharing some resources, or maybe even in terms of something manpower resources itself. The many issues we have, right? Particularly for the water reservoir system. So we have to monitor continuously. That's why if you are monitoring perfect way, then obviously easy to get the water throughout India. Same time our agriculture, many factors, living things also possible. So finally, how to do it? By using the IoT platform for structural health monitoring. The long day, I think long back, how they actually monitor the structural health monitoring by the civil engineers itself. Because experts, they are subject expert. We are actually the technology expert. That's all. Here, the possibility, when after completing this session, students will be getting the idea. Okay, how to start up a company, in this particular field. Today the demand is very simple. Today in India we need such startup company in this particular field. Civil engineers actually lagging. They don't know this particular technologies, right? We have to monitor it after once the construction done. That's all. Their job is to, for example, physical monitoring. That's all. They will be coming, there will be something non-destructive testing or something. Normally they will be doing it at the pillars or somewhere at the structures, but without disturbing the structure, right? By sitting away some, or maybe the half kilometer, or maybe the 100 meters or 50 meters away, we have to keep one sensor, right? We have to understand what exactly the vibration is, there any movement, physical structure movement, alignment change or anything. We have to monitor it. No need to stay there. System will be doing everything with the help of artificial intelligence, right? All the data will be stored. If any issues are gonna rises, right, that time will be getting the alert to the expert, to the local on a disaster management team. Immediately, if any system is getting collapsed, okay, now this on due to, for example, maybe the slight earthquake. For us it's hard to understand. Okay, minimum slight earthquake. Okay, this particular structure is getting, actually day by day it's actually degrading the performance. It's very simple. Immediately the particular sensor will be giving the alert to the local disaster management team. So easy to, for example, if any man actually easy to relocate the on manpower inside, actually what exactly the number of manpower, or maybe, for example, other things, right? Maybe the animals or anything, right? Easy to relocate. Same thing, easy to, for example, stop the collapse, right, at the earliest. So easy to, for example, where exactly the problem at the earliest, it's easy to identify it. Such things easy to do that. Okay, what exactly happened in 1930? Just see that after the construction, right? That's a beauty. After the construction, each and every year they'll be keeping some 5 years or 10 years gap, right? Each and every 10 years once they'll be going there, somewhere in the bridge or somewhere in the dam, right? They'll be removing some concrete structure or something. They'll be breaking the concrete structure. They'll be checking what exactly the quality of iron rod, or maybe what exactly the leakage or something. Intentionally they'll be breaking the physical structure. Okay, they'll be checking it. No, okay, there is no leakage. You see that in their own they are fixing based on some theory. Previously, actually based on the something failure theories will be there. Okay, this particular dam or something in the bridge collapse based on this particular reason. So then they'll be checking only at the particular bridge. Okay, only at the particular pillar. The reason maximum this particular pillar is actually actually on loading the maximum weight or something. Okay, they'll be having this many theories. So based on that, they'll be removing some concrete structure. They'll be checking internally what exactly normally happens. This is what actually even today in I think last few years before, particularly in I think nearby Tamil Nadu, one of the dam is there, some controversial dam. There we have actually some few years before, actually Supreme Court of India actually formed one team. Actually still they did recently, they did actually remove intentionally, they have checked the particular dam. Actually after that they have checked with some digital sensors also. When you are checking physically, actually when you are damaging the concrete or something, the main problem, sometime maybe the crack occurred in the some other place, right? By mistake, if you have missed that one, that's all. Hard to, for example, save the dam or something, any structure. So this particular monitoring systems actually happened in 1930s. Okay, so after that, just see the beauty. After that, electronics engineers and electrical engineers are getting into that. How we are actually protecting these particular structures. Okay, how to actually protect this by using the sensors. Sensors and actuators are either embedded or attached to the system. It's very simple. That is nothing but the device. Okay, whatever it may be, the device. The structures which contains Sensors actuators can respond to the counteract loads, reduces vibration, change in shape, prevent wound degradation. Over the years, right, due to, for example, the age, right, over the years, right, obviously the self degradation will be there, just like the human being. Any structure, even in your home itself, you can see the self degradation will be there day by day. It's hard to, for example, understand. So what we have to do, just like a doctor, right, just like the every year on a treatment, right, we have to do the few things. Then when we are doing such things, means so we can increase the survival time. That's all. The use of these sensors will improve the performance of structures, safety, durability, reliability, decreased time, life cycle. Okay. And reduction of physical dimensions and weight. Applications of sensors. Right now, actually, digital transformation, after the digital transformation, structural health monitoring systems, inspection of fatigue cracks, seismic damage identification. Maybe later we are going to detail this. We are going to discuss about this particular technical term. Being electronics and electrical engineers, right? There is no point to worry about that. Where we are going to discuss about on a concrete technology or civil engineering technologies. Not at all. We will be discussing only about our technology. That's all. But we have to give the particular contribution to them also. So there is a possibility. There is a gap for particularly for Indians, right? To start a company. If you are able to start a one company to identify only for the, I will be providing, I can able to give a, for example, 24/7. I can able to monitor your particular structure. I'm ready to, for example, share the data to you directly or to the local disaster management team. I can do. If you're able to develop such on a startups, right? We actually need not one or two on the startups. We need actually 1,000+ startups. Actually, we need, because in India we have ancient temples as well as ancient structures we have, right? Still, actually, UNESCO certified structures itself we have 100+, right? Many structures we have, so we have to monitor it. So we need around 1,000+ startups are required in the variety of throughout actually India. What is structural health monitoring? First we should know that what is structural health monitoring. The process of implementing a damage detection and characterization strategy. Okay, characterization strategy. Okay. Okay, how we are defining the damage actually? The damage is defined as changes to the material or the geometry change, the geometrical property change, right? The structural in the structural system. Obviously, when actually we have designed one particular structure based on the geometry, when the change in geometry, right, obviously it will affect the overall system, right? In the somewhere in the actually we have experienced, right, that recently in India itself, initially the apartment constructed, after that, hello, is it okay? In India itself, we have experienced, even in Chennai, I think few years before, actually in Tamil Nadu, we have experienced initially they have designed one apartment roughly about some 25 floor, right? After a few years, actually the change in shape. Then after that, government decided that, right, just collapse it. But it's not at all required, right? Almost just think that what exactly the manpower involved, what exactly the cost involved, right? If you have kept one sensor, okay, so slightly we have a doubt, slight changes is there. Okay, it's very simple thing. Just try to keep one sensor. Obviously, it will be sensor will be giving the idea. So at the earliest, easy to, for example, give a protection. Protection is nothing but today the civil engineers have a lot of techniques. Slight changes there, I mean they are still they can able to put lot of concrete on something just like a liquid concrete to the basement. Maybe the basement is actually the roughly on 50 meters below. It's not a problem for them. Actually, they are ready to inject the concrete, fluid concrete, cold concrete to the basement. So they have a lot of technology to protect the system, the structures. Okay, we'll see. So we have to give an input to them. That is our aim. So SHM aims to provide real-time data, the reliable one, information regarding the integrity of the structure. Obviously, our aim, this is what our aim. SHM technology can detect and identify the invisible damage in the components before complete collapse or failure. The techniques for real-time SHM are Just very simple. Just see how we are going to detect. It's very simple one. The techniques for real-time structural health monitoring are ultrasonic sensing and fiber optic sensing. Okay. I'm not going to dictate all the things. Okay, I will be giving the idea line by line. This idea I'll be giving. Okay. What exactly the ultrasonic sensing? It's a very simple one. It's actually very straightforward. Whatever it is there, it will be giving the output. Very simple. When you're actually passing the ultrasonic sound, that ultrasonic signal, right? When it is actually hitting the somewhere in the structure, obviously it'll be getting back the signal. If it is any on the cracks, the micro cracks, everything you can able to map it. Easy to map it. After that, actually, if it is a steel structure, maybe just think that we have actually on a UV light, right? Then, for example, if you want to still, if you want to understand inside the steel structure, right, without disturbing it, today we have the non-destructive testing. Mechanical engineers are very on, they are working on that non-destructive testing. Okay. However, ultrasonic sensors and actuators require separate electrical wiring. Perform just see that perform poorly in the harsh environments, but fiber optic sensors, on the other hand, offer stable output in the even in the harsh environment. Harsh environment is nothing but maybe more during the time of cyclone or during the time of any the time of earthquake, right? Any time. Fiber optic signal, right? Obviously, maybe the light in terms of light communication, maybe with the help of Li-Fi, light fidelity communication, right? That is a reliable output you can able to get when compared to the ultrasonic, somewhat better accuracy. This is what I like to convey it now. This particular sensors are giving actually reliable data in the real-time monitoring for various structural changes like stress, strain, internal micro cracks, and everything. Right? Fine. Okay. These are the things actually we have discussed. The modern tech, with the aid of modern technology, real-time control of structures, right? Active control systems, right? Information sensors are just monitoring system with the help of data acquisition systems that is easy to monitor it. Okay, I'm sure I don't have much on the theory content. I have the many images, right? So easy to interact. You'll be getting, you won't get any boring or something, right? So just few slides just for to convey what exactly the idea. That's all. Okay. Example of sensors for minimal general complex SHMS, structural health monitoring system. Okay, the minimal, very minimum cost on systems. Okay, this much. Okay, slightly above general. What exactly are we are actually trying to use the technology? The next one is nothing but slightly complex. When we have the complex structures, right, that time we can go with the this particular things. Okay, where we need particular complex structure? Yes, particular just in Gujarat recently we have built up the Sardar Vallabhbhai Patel on a statue, right? There we need the structural health monitoring system. Why we need the structural health monitoring? Around we have actually the actually not the government of India money, the many the organization, right? The supported to fund I think roughly about some 3,000 crore. I'm not sure exactly the amount, right? Something around the 3,000 crore amount, right, to build a statue of for the Sardar Vallabhbhai Patel. To that is the Statue of Unity. Okay, there actually why we need to monitor it? It's very simple thing, right? If we just think that even a small actually the piece of portion is actually damaged, just think that the people all the time around the day during the daytime, during the visitors time, right? How many of actually the human beings actually surrounded that human lives, right? Safety. The second one, how much time we have taken, how much manpower, how much, for example, the particularly the equipments, many things, right? We need to once again, if the repair or something after the damage or something, once again we have to close it. Obviously, visitors cannot able to penetrate on the pass through that. So for next 1 or 2 months will be closed, right? Such issues as we have. So in advance we have to monitor it, particularly for the Statue of Unity. Okay, such a system if you want to monitor mean complex system we need node by node. This particular Statue of Unity, just take the Statue of Unity, right? It's very simple. So we have to split it into the 100 mesh or 1,000 meshes. Meshes is nothing but a part point by point. Just like in on the head of the Statue of Unity itself, you can there many too many plates are there actually. If you are interested, mean please check it how actually they have constructed the Statue of Unity. The video is available. The government of India actually released the video, right? The video itself they have shown the many tons of plates, steel plates are there. So it's very simple. On the head itself, there we can see the on the exactly the forehead, many ridges will be there to exactly map the face of Sardar Vallabhai Patel. So many ridges will be there. So how they are developed it? So many nodes will be there. So each and every node we have to try to give our wireless sensor should try to focus that. Okay. If any change in the particular node, right, it will be giving the input. Okay, slight change in that particular area. Okay, we have to look on that. Okay, then we have to refer with the reference one, just 1 month before or 2 months before, how it will be. Because we have all the data in the data acquisition system. The data acquisition system will have the comparator. Okay, the comparator job is nothing but simple. All the time will be compare the with respect to the previous results as well as the coming results. Whatever the results right now actually we have. Keeps on comparing the results. Fine. So there we need the complex structure, particularly in India. Okay, first we'll go through the minimum. Okay, the technology what we need in hand: weather station, temperature sensor, fiber optic sensor, corrosion cell, inclinometer, biaxial accelerometer. In that, actually, few things are actually comes under on a civil engineering point of view. Few things are actually comes under mechanical engineering perspective. Few things are comes under instrumentation engineering perspective. Very few things are very very few sensors are actually comes under electronics and electrical engineers, right? All the time. If electronics mean, obviously the electrical engineers also are on fellow mates, right? So here, what are the things are there in electrical and electronics engineers? Fiber optic sensors, right? Very simple, fiber optic sensors. Fine. Next, general category. What are the things are in general category? Laser displacement sensor, very simple thing. This actually comes under our electrical and electronics engineers. Global positioning system, our communication engineers will be getting the possibility to work on that, right? Just an expert, technology expert. Then weigh in motion, okay, the mechanical engineers, triaxial accelerometer, anemometer, humidity sensor, we can do that. Groundwater pressure, right? Seismic accelerometer, okay, fine. Few things we can able to do that. Electronics and electrical engineers. Then complex structures, what exactly the complex structures? Road wear sensor, right? On road, throughout on the road, right, how to keep the sensors, right? Where we have to keep such sensors means simple thing. Just for example, particularly when the hill station, right, where exactly the landslide occurs. So recently in Kerala, if you're actually noticing throughout India, right, on a long back, I think roughly 10 years before Uttarakhand, right, there is a because of the landsliding due to the flood, right, the landsliding, right, almost 1,000 plus our Indians, right, the fellow Indians, right, on on particularly in this particular on close to that particular temple. So hard to, for example, relocate them. So what we did with the help of a disaster management team, I think they did. So if we need the particular, for example, structures right on road, if we need the particularly Uttarakhand or maybe nearby the Kerala actually every month during the time of that rainfall season, you can easily notice that every day or every week we'll be getting the landsliding problem. So because of landsliding, road transportation completely stopped. Then what next? The people who may not be getting the vegetables or milk or anything daily things, right? What exactly they need? Household things is hard to get it. What next? Maybe it will be sometimes it will be affecting the human lives also. Fine. Then microwave interferometer, radar, acoustic emission sensor, pyrodometer, photogrammetry, hydraulic pressure sensor, ground penetrating radar, bridge WIM, thermography. Few things are actually we are going to discuss in detail. What are the things we are going to discuss? This is what we are just I have marked in the underline, red in color. The very under the minimal category, fiber optic sensors, strain inclinometer, right? This actually comes under in our on electronics and electrical category. Next, laser displacement sensor is there. Actually, we are not going to discuss in detail. Slightly, we are going to discuss that's all. Humidity sensors in under general category. The complex category, right? That is actually we should know that, right? What is minimal? What is on the application of general on category sensors? What about the complex sensors, right? Where exactly we have the complex structure, there we have to apply this one. Okay. Microwave interferometric radar, ground penetrating radar, bridge WIM station. Later we are going to discuss in detail about bridge SHMS. Okay, we'll be getting on. Will be enjoyed, right? We have the many images. We have to on a go all around on a Europe as well as the United States. What exactly structure they have, right? We have to discuss in detail. Okay, so stay in line. Okay, what is SHM? Structural monitoring system. How they are actually collecting the data. Okay, that's all. This particular flow chart will give you the idea how we are actually monitoring the structure. Okay, how we are actually loading the data and how we are actually comparing the data with the previous data. Right. If anything goes wrong, how it is actually informing to the local authority or the corresponding authority, the team of management team. Initially start, as usual, the flow chart begins. Read the piezoelectric transducer, fine, followed by, right, any sensor. Here we have taken the piezoelectric transducer. Maybe you can keep any kind of sensor. The sensor apply the cross correlation. Just see that cross correlation, they are taking it. Okay, if it is healthy, just see that this particular healthy section have the sensor. There we have the comparator. Sorry, there we have the comparators. This particular comparators all the time keep on tracking the data. Okay, if it is yes, no problem. We'll be proceeding with that. Send status to the internet server. Okay, IoT completed. One, each and every second is actually, this particular flow chart is actually completing each and every second. If whenever it's actually facing the problem, it will be giving the recorded. Okay, then that time the main problem is nothing but when you are working with a digital acquisition system, the main problem today, we need artificial intelligence. The reason why we need artificial intelligence is very simple thing, because each and every second we are recording the data, we'll be having at the end of the day or at the end of the month or end of the year, we'll be having the bulk number of data. But you should not think that why we have to keep the bulk number of data. Means very simple thing, I will tell you. Just open your mail, Gmail account. If you have subscribed many on Google Scholars citations, or maybe if you have subscribed many on some online portals or something, means you'll be getting the advertisement, you'll be getting the many things, right? Then think about that, how you are going to actually, every day you are getting 50 emails, some junk email or something. Some few junk emails will be actually identified by the Gmail account itself. Okay, under spam. The few things will be there in general, right? We have to check one by one. Sometimes we'll be forgetting to check. Okay, very first page you'll be looking at it. Okay, today this much only it is there. That's all. We'll normally leave that. Then think about that. Around 1 year, 365 on a day, the data taken each and every second or each and every minute or each and every hour, right? The periodic is actually fixed by the authority, based on the requirement. Then think about the bulk number of data will be there. So we need artificial intelligence. Why we need artificial intelligence? Whenever artificial intelligence is nothing. It's very simple thing. Now I'll tell you what is artificial intelligence. Whenever the comparator is actually feeling that it's the data is matching, it's not matching with the previous data, then it's actually the fishy, something fishy. If my data is not matching with the previous data, not matching with the previous my reference, okay, then something is fishy. Okay, my document is not at all matching, then something is fishy. Then this particular document will be keep it in the separate register. Okay, separate one. You have to look it at the earliest. Okay, this is very important. Just like the star the mail. Now normally we used to keep it after getting mail, one star is will be there. Just press the star. Whenever if you want to see the star mail, you can press the star folder, right? You can see that okay, these are the mail are very important. Same way we'll be getting this particular issue is important. Just please look into that. Okay, just based on that, just take the action. Then you'll be getting an action button. No, just leave it. That's all. So what next? Artificial intelligence, it will be giving the if you're connected with IoT, mean normally it will be giving the mail to the wherever you want, they will be sending it. Otherwise, you can say that no human manpower is needed. In your own, you can decide. Then you can see create one flow chart. Okay, this is what. Then based on that, just a reactive. It will be doing in its own. That's all. The data acquisition system, right? These are the things are actually the very basic things only I'm discussing. Later we are going to discuss about that one in detail. Slightly I'll increase the speed. Okay. Around we have discussed very much in detail about the basics. Data acquisition system flowchart, just very simple. The basement is nothing but sensors on the structures. Sensors on the structures. Okay. Throughout the system is actually data communication system actually enabled. Fine. Interrogator, okay, just actually the data processing system. So digital to analog conversion, analog to digital conversion, wherever it is required, right? It will be converting whichever the on a day actually analog, usually the sensor output will be in the analog, right? We have to convert into the analog to the digital conversion, because our system, our platform only can able to understand the digital output. That is the reason we have to convert it. Rest of the things will be stored in the cloud. Okay, we are entering into our on the subject. Ground penetrating sensor. Actually, ground penetrating sensor comes under complex system. Okay, just see that this actually the man is actually a very simple thing. The concrete road or maybe the tar road or anything, any kind of road, right? Actually developed or created or I think is carved by the civil engineers, or maybe the automation systems. Nowadays, actually we have the automation system, right? Even in the railway and the paving and actually the track paving also, we have the automation systems. Fine. After that, we have to monitor it. It's a very challenging one. Monitoring the structure is not at all the challenging one. Monitoring the road or maybe the railway track is very, very challenging one. There actually many number of the human beings are involved there. Just think that throughout the day, in throughout India, particularly throughout India, all the tracks will be monitored each and every day. Will you accept it or not? They are doing it. In particular, Indian Railway is doing that. They have the particular railway station that they'll be keeping it. 10 kilometers is nothing but are 5 kilometers under their control. Particular railway station, particular track. Each and every day, with the help of that, human beings are involved. They are each and every day are checking it. The check by note, they are checking it, right, throughout India. Just see that how many number of human beings are involved in that. See, so if we, there we need the digital, right? If you are able to provide that, then your company, your startup company will be getting the project, no doubt, under the digital transformation. Fine. What is ground penetrating radar? The surface antenna. Just see that there we have the surface antenna. A surface antenna of a GPR, ground penetrating radar, propagates. It's very simple. The radar, right? Waves in distinct pulses. The distinct pulses will be transmitted. Then what next? Obviously, it will be reflected back to the radar. Reflected off buried objects in the ground, right? Obviously, it will be detected where exactly the crack or something, any damages inside the structure, right? Maybe on the road also. Don't think that initially the government of India, for example, 1 kilometer or 5 kilometers, just think that 4 line or maybe the 6 line road, they are investing around some 1,000 crores or something, maybe for a 100-kilometer project or 5-kilometer project or anything, right? Then, yeah, after, for example, 1 year or 2 year, once again, if you are facing the problem, just think that it's hard to, for example, hard to put once again, for example, 1,000 crore or maybe 500 or 100 or 20 or 1 crore or even 1 rupee, right? It's a waste of time. Simple that if you are ready to one company, okay, the particular project is outsourced by one private company or startup company. They will be taking care for the next 100 kilometers. Okay, their job is nothing but wherever the problem occurs, their job is to inform to the local authority. The road transportation authority will be informed. Okay, their crack is there, just remove it. Then the road life initially is actually 2 to 3 years, then it will be increased to 10 years or 20 years. That's all. That is our aim. Because actually we are populated. Still, if you are putting our money, our maximum amount of money, right? Almost we are putting our maximum amount of money on road or same road for repairing the road, right? It's very difficult. So we have to put on the newer project, new innovation project. Then we'll be growing day by day. This is what exactly the other countries, the developed countries are doing that. Okay, even particularly the European countries are doing that. This is very, very challenging one when compared to the monitoring the bridges or dam, this particular project. When radar pulses are being transmitted through the various material on the way to the buried object, right? What exactly happening? Velocity changing, obviously, right? Due to the change in velocity, easy to understand because already in the database we have. Okay, the velocity changes. What exactly normally happens inside the structure? We'll be having all the everything. Okay, this is a velocity, then this is a problem, equivalent problem. Then easy to get an idea. Everything today is nothing but automation. So our job is nothing but we should have, even particularly Tamil Nadu government is already doing after in the particularly in the 4-line highways. What exactly they are trying to do that means very simple thing. In the normal bus-like structure, here actually the human being is involved, right? Actually, Tamil Nadu, what exactly the government is doing in bus-like structure, there will the exactly the front, there will the pumper will be there, right? The front pumper as well as the back pumper will be there. They have attached one sensors, many sensors they have attached it. The bus will be moving the constant speed throughout Tamil Nadu or throughout this particular 100 kilometers per day. They are fixed. Only thing we have to put fuel as well as we have to pay for the driver, and we have to think about the maintenance of the particular vehicle. That's all enough. So after the particular day, okay, it will be giving the idea. It's actually connected with the GPS, right? It will be giving all the latitude. This is exactly the position, everything it will be getting it. After that, the data will be given to the local authority. The local authority will be verifying all the data. Then easy to solve exactly repair the particular spot. This is what exactly they're doing it. Fine. Interferometric send on a radar. This particular interferometric radar is actually on a monitoring on a bridge monitoring on a device. One second. Interferometric radar kept. Just see that there we have one image. The interferometric radar equipment kept in front of Manhattan Bridge. Manhattan Bridge. Okay, this is what we are going to discuss hereafter. Only based on our on radars as well as optical devices. Okay. This particular measurement device is nothing but coherent radar. Coherent radar. This instrument generates, transmits, and receives the electromagnetic signal to be processed to provide movement or deformation measurement. The change in, for example, the change in structure, right, easy to measure it. The location, alignment are slightly changing, okay, easy to know that. The measurement is actually static as well as the dynamic measurement of structures can be performed. Obviously, these techniques are actually non-contact method, right? No need to break or no need to, for example, no need to damage intentionally any part of the system. Any part of the system. Right. Here actually it's on this non-contact method to measure object distance up to kilometers is convenient. You can keep this particular system 1 kilometer away. No need to keep exactly nearby the bridges. Why I'm trying to say that 1 kilometer away, maybe this particular bridge maybe look kept in on the sea, adjusting that. It's very difficult to keep one boat exactly nearby the on bridges or somewhere in the dam are very difficult. Mostly in our dams are in particular India is located in the mountains or in between the two mountains. They're hard to keep it. The main problem is nothing but the disturbance due to the animals or disturbance due to the cyclone or disturbance due to the vibrations, noises developed. Noises is nothing but the vibration. Maybe the change in shape or something due to trees or due to animals or due to anything, right? Such problem. So we can try to keep 1 kilometer away or kilometers away. So easy to detect it. So simple that time we have to increase the intensity of the signal. When you're increasing the intensity of the signal, obviously the sensitivity will be increasing. Fine. These are the things actually we are discussing the normal radar application. Okay, when you are getting into the optical devices, right? What exactly you are going to get? It's very simple thing, accuracy. Why we need the optical system? Accuracy. One more thing is actually the beautiful thing. Obviously, slightly the many minimum negatives will be there. So social activists will be taking that, oh, radiation hazard. When you are working with many number of antennas, sure, it will be damaging the grow for it will affect the animals or something. They'll be coming with many stories, right? They'll be have the many stories, or maybe the reality also may be there, right? So why we need the optical system? Sure, there is no harmful to, there is no radiation hazard. That is the beauty behind that. Still, due to the cyclone or due to any, for example, atmospheric disturbance, sure, it is hard to disturb it. It's a reliable data. Fine. So here we have the images. Those are working with optical engineering, right? You know very well about this one. This is nothing but a display of splicing machine. Splicing machine is very simple thing, I'll tell you. Just take a wire, normal copper wire. Okay, copper wire. With the help of cutter will be the right. Just with the help of cutter, just with the help of cutter, cut the wire. Okay. After that, just try to join the copper wire. What normally we'll be doing that at the edges we used to, for example, with the help of knife, right? We used to remove the insulation. After that, on the other part of the wire also we have to remove the insulation. Then we'll be trying to joined it. After that, the insulation tab will be there, right? We have to find the insulation tab on the copper wire. That's all. This is what normally we are doing it, right? Obviously, resistance occurs. We are not at all bothering about resistance, because very simple thing is nothing but 0.7 electron volt normally occurs. Same way, we are ohmic contact losses. Many things are associated with that. We are not bothering about that, because sufficiently we are getting the energy. Sufficiently we are getting the electrical energy. That is the reason. But when you are working with optical systems, right, the slight disturbances are enough to damage our original data. Slight disturbances are enough to damage the original data. So when you're working with fiber optic sensors, splicing mission is nothing but it's very simple thing. You can cut the optical fiber optics, right? Fiber optic wire. Then later you can join the two wires, pin wires. Then after joining, you see that the decibel, you see that the display of splicing machine after fiber fusion. Perfect result with 0 dB loss can be seen to the left. Poor outcome with 0.8 dB loss to the right. You see that 0.0 dB loss can be achieved. That's a beauty in the fiber optic sensor systems. That much, even 0 dB loss itself is not possible to occur, right? So easy to, for example, zero loss. That's all. That is our aim. Types of sensors. Still we have, I think I'm sure, still we have 20 more minutes. Okay, it's enough time to discuss that. Okay. Still, we'll be getting some interesting slides. Okay, hereafter there is no more technical things. Here we'll be getting the common things related to our engineering. Optical fiber sensors, optical fiber grading sensors, FPGS, nothing but piezoelectric sensors, humidity sensors. Okay, what is a fiber optic sensors? Fiber optic sensors are actually in general operates over a range of wavelength. In that 1550 nanometer, actually those are working with optical engineering, right? They are very familiar in that. 1550, right? Nanometer wavelength is a suitable one, standard one for the minimal loss. For minimal loss, that is a standard one. They are generally divided into two kinds, single mode as well as multi-mode fibers. Many applications of fiber optic sensors uses single mode fibers with the core diameter of 5 to 10 micrometers. 5 to 10 micrometers. Here you can see that slightly with the help of fiber optic sensor, if there any damage or something, right? This is particular, this one is actually on OTDR measurement, right? The checking losses of optical signal in the tap sensor, right? Somewhere I have actually, there is actually the change in the signal. So I have projected in the right hand side. There you can see that some damage is there or something. Crack is there. Easy to identify the micro cracks also. That is our aim. Okay. Little more idea about the optical fiber sensors. Fiber optic sensors sensing wide range of things. What exactly the parameters? Temperature, displacement, vibrations, pressure, acceleration, rotation, measurement of deformations. Penetration of chemicals, you see that penetration of chemical, even in the nuclear projects itself, the people are working with this one. After the collapse of the Fukushima due to the tsunami, right, in the Japan, after that the people are ready to work in a remote area. Even they are ready to sit on after 10 kilometers or 5 kilometers away. They are ready to, even if anything happened, right, they are ready, for example, control the things. What exactly is happening? What exactly happening? Even you can check on Chernobyl. We know that Russia, that nuclear on vessel actually blasted, right? I'm not sure about the year. Okay, we have some in the school days. We have read many case studies that Chernobyl disaster. The Chernobyl disaster still actually, I could recently, one of my friends visited Chernobyl in Russia. What he has commented that still the emission is there. Still emission is there. The European countries are actually still reporting that actually emission. We are actually facing the emission even 1,000 kilometers away. European countries also facing that. Yeah, still the emission is there. Then they have formed one forum. A particular forum is job is to nothing but how we are going to stop this one. Then they have created one based on their forum. They have actually decided to create one the big sized vessel. Vessel is nothing but just like a shield. Okay, it's nothing but the steel on just like steel on just like a cap. Steel cap, nothing but normal cap. How we normally the human beings are wearing. Okay, the caps like structure. They kept the particular cap exactly on the particular the blasted vessel. Now almost slightly reduced the emission. Okay, so Even after 20 or 30 or 35 years, right, still we are facing the problem. So in advance, why I'm explaining these are the things, because once happened, then hard to stop it. Then obviously the effect will be very high. So we have to, at the earliest, we have to identify, or at the earliest we have to detect it. Then it's easy to solve almost all the problems, easy to repair it. That is the aim. Okay. In general, principle of such devices is that it's very simple thing, right? Laser emission will be there. Okay, how it will be? The light, the devices is that light from a laser, often the single frequency fiber lasers will be there, or form of super luminant sources will be there. Such things will be there. Okay, fine. So this particular light will be sent through an optical fiber. Experience subtle changes will be there, slight changes will be there in the parameters in the fiber, then reaches the detector. It's very simple thing. The light is nothing but it will be transmitted through the fiber, right? It will be reaching the detector. Okay, in between there will be having some our require based on the requirement. Will be trained to keep the sensors. That's all. Coherence on the sensor. Many kind of sensors we have, right? Easy to keep in between that. Later we are going to discuss that one also. Okay. Advantages of by using the optical fiber sensors. They consist of electrically insulating material that can be safely used in the explosive environment. Just now we have discussed about the Chernobyl disaster, right? Maybe in the Fukushima disaster. Because there is no risk of electrical spark. That is a beauty. That is a beauty, right? No, there is no electrical spot. Obviously, this particular light will not create any harmful effect to the chemical or not harmful effect to the any kind of the nuclear on the explosives, right? Sure, it will be passing through that. It will be observing what exactly the property, what exactly the environment, whether the human being can able to step into the environment or not. That's all we want to know that. In advance, so right, in the other we have to relocate some on the neighbors or not. Easy to know that. Their materials can be chemically passive, obviously. Do not contaminate their surroundings and are not subject to corrosion, no doubt. They have very wide operating temperature range. Now we are going to discuss FBGS, fiber Bragg grating sensors. This is a measuring device. It's actually purely based on the wavelength dependent reflector, right? Formed by introducing the periodic refractive index structures. Okay, now we are going to discuss about that. N1, N2, N3 will be changing the refractive index structure with the spacing on the order of wavelength of light. Right. FPGAs have been widely used for monitoring of civil structures. Right now, they are working on that. This particular FPGAs comes under general category as well as the minimal category nowadays. Like highways, just see that where exactly it has application. Highways, bridges, buildings, dams, etc. Remote sensing of oil wells also. Power cables, pipeline, space stations, etc. Why we need this particular sensors? Mean recently government of India has actually launched one. Actually, already the implemented project is nothing but we have actually connected the data cable to the Andaman and Nicobar Island. Actually now they are getting the high on the speed the data. How they are getting? They have government of India actually installed the fiber optical fiber cables on the sea. Right? How actually after that how they are actually monitoring it with the help of is nothing but the wireless sensors, wireless optical fiber sensors. So where exactly the problems comes, right? This particular disaster team will be reaching there, immediately the problem will be solved. Same time, the government of India is connected actually the two way. One is from Kolkata to Andaman and Nicobar, and other part. Okay, why they are trying to keep in the both the way? If anything actually damage, maybe due to the enemy or due to the enemy countries or due to the animals or anything, right? The fish, anything, right? If any damage due to the any other on natural issues, right, happened, automatically it will be going with the bypass. Other one will be there. Okay, the withstanding. Okay, it will be other one is nothing but the bystander. Okay, okay. After the once the problem solved, okay, the two are ready. The two channel will be ready in condition. Okay, how the 5 FPGS is working? Normal fiber optic sensors. I am sure if you are those who are actually second year, third year, I'm sure you are not actually studied about optical fiber engineering. Right. This is very simple fiber. Just look like a coaxial cable. Right. Simple. The top one is nothing but the cladding will be there. The center one core will be there. At the core only there we have marked the blue in color. Right. The change in slightly change in sky blue in color. They have there we have marked N0, N1, N2, N3 is nothing but the refractive index. So core refractive index, just see the value how it is actually changing with the periodical changes. Then spectral change, how the input will be there, transmitted one, reflected one. Where exactly the problem occurs, right? It will be reflected one. So easy to identify the location spot. That's the aim. Okay, this is nothing but the very basic things. The advantages already we have discussed about the fiber optic sensors. High strain, lightweight, immune to electromagnetic interference, right? Signals are not distance dependent. So you can increase a distance. Long-term stability is very high, obviously. Good corrosion resistance, very low magnetic field interaction. So the enemy countries, right, by increasing the magnetic field interaction, right, disturbance, right, they can stop our communication, right? They can't do that. Obviously, we are actually we have the technology to prevent that one also. Then piezoelectric sensors. Piezoelectric sensors are used to detect the crack in the structure. Crack in the structure. The strain changes caused by the cracks in the structure are relatively small, and resulting variation of the voltage output of the piezoelectric sensor, right, easy to measure it. For the reason why we are actually going this particular detection strategy, the two piezoelectric sensors are in general will be used, okay, conveniently measuring the voltage difference between the two piezoelectric strip sensors. Okay, this right now actually on today real time piezoelectric sensors applications is very minimum. Previously we have used a lot. What exactly, how they are actually doing it, particularly dam or pillars are everywhere. After identifying the location, okay, where exactly the detection by the help of wireless sensors, right, will be transmitting the signal. Okay, particularly in the pillar, there we have the problem. Then after that also piezoelectric sensors, with the help of piezoelectric sensors only, without damaging the structure, we used to measure it. Okay, if the signal is actually this not at all penetrating, then it will be returned back. If any damage is there, then it will be pass through the damage. Wherever the actually damage is actually reaching the cracks, till that it will be going back. So easy to understand the depth of the crack. That is the aim by using this one. Okay, almost the end of on the theory part. Humidity sensors. Humidity sensors are nothing but a microwave reflection of concrete at the different moisture condition. Microwave reflection. That's all. Different moisture condition, right? Easy to measure the on things. The humidity sensors measure two parameters for evaluation: electrical resistance and temperature. The two things only normally it will measure: electrical resistance and the temperature. The two measurements are performed at different depths, typically placed between the concrete surface and reinforcement bar. Many things. I have the images, so you can see that. This allows a evaluation of water content across the concrete depth. Okay, we'll see that. This is the installation of moisture sensor. Okay, this is an ideal condition. Okay, this is a kind of how they are trying to keep. Corrosion sensor. Why we need the corrosion sensor? Because particularly in the dam, such structures, when we are going for the bulk structures, right, we should have such sensors. Then only we can able to understand when actually what exactly the survival, everything easy to understand. Because steel bar is nothing but the backbone. Steel bar is nothing but the backbone of the structure. So we should know that what exactly the corrosion resistance. Okay, we are entering into the now we will be going to the slightly the world tour. Okay, what exactly the structures are there, how they are monitoring it. So you will be getting the idea. This is actually happening today, Europe as well as the United States. This is actually after the I am sure after getting after the installation of Statue of Unity only I got the idea to create this particular the PPT. The reason is nothing but India itself is actually are entering into that. Even few state governments already monitoring the road. Already the Indian Railways actually monitoring the track each and every day with the help of human beings, right? If you're able to reduce that, then think about cost will be reduced, right? Simple. Still, the growth will be improving that. How we are commenting the growth? Yeah, the particular amount of money, right? The investing day by day will be actually passing to the other innovation projects, right? So easy to get a development. Otherwise, day by day we have to work on the repair work only. So we'll be investing our amount day by day on the same project. That is waste of money. So bridge on health on a structural health monitoring system. This particular bridge actually is in Greece, named Rio Antrio Bridge. Actually has more than 100 sensors monitoring the structure and the traffic in the real time. You see that 100 sensors are there. Okay. one of the world largest multi-span. This particular, just see the cable, both the bridges are same actually. The very first image is nothing but there you can see the very long, the distance, right? After that, just see that I have taken only one, the particular pole, only the particular pillar. The particular pillar is actually connected, how they are connected with the help of hanging span, right? How the actually cables are there, stayed cable stayed bridges, right? Simple. Such bridges are there in even in the Mumbai also. Recently, they have developed it. In few on Tamil Nadu also, few cities we could be able to see that. The British developed bridges are still it is there. The olden days bridges with the help of cable stayed bridges. One of the world longest multi-span cable stayed bridges, longest of fully suspended type. It opened in 12th August 2004, length around 880 meters. Just see that? Okay, it's actually in the Greece. This is very simple one. Just see the bridge, other one. It's actually Millau Viaduct in France. Okay, see the beauty, how they're actually monitoring it. It's very important thing is how much time they have taken to build this particular bridge. So you have to monitor second by second. Okay. Has one of the largest system with fiber optics in the world, which is considered state of art, obviously. Millau Viaduct is a multi-span actually cable stayed bridge completed in 2004 across the gorge valley of the Ton near Millau in actually the southern France. Distance 2,460 meters. Here also the fiber optic systems are used. Fiber optic sensors are used to monitor the structural health monitor this particular bridge. Okay. Fine. The next one is actually in USA. This particular bridge in the right hand side, just left hand side, you'll be getting this normal one, right? Look like a normal one, just look like a Kolkata or a bridge, right? Normal, the old Kolkata bridge. But here, this one is nothing but just see that here you have the railway track. The center, the two tracks are railway tracks. Left hand side, right hand side, there you can see the road tracks also, the normal road transportation tracks also. How they're monitoring it. Just see that you can say it's very simple one, right? It's very difficult. The reason it's very simple thing. In Godavari, actually, those are actually from Andhra Pradesh, right? The Godavari bridge, you see the longest, right? The longest one. Same time, they are trying to keep other one is nothing but not exactly close to that, the railway bridge. Railway bridge is almost, the thing is nothing but railway bridge means the vibration will be very high. When you so here the railway bridge along with the road highly challenging one, because the frequency should not match the road transportation. What exactly the frequency, what exactly the frequency of vibration for the other one, it's sure it won't match, right? So hard to keep both at a time. That's highly challenging one. That's why Huey P Long Bridge USA has over 800, just see that, 800 static and dynamic strain cages are used to measure the axial and bending load effect. Just see that the old bridge, right? How they are monitoring it. This is what 800 static and dynamic strain cages are used. This is a mechanical way of evaluation, right? Still, we can able to do with the help of wireless sensors. Wireless sensors also they are working with that. It is a cantilevered steel through truss bridge, right? That carries a two-track, just see that railroad, the center one, two-track railroad line over the Mississippi River. Actually, the under one is a Mississippi River. Opened in December 1935. See the beauty, 1935, almost close to 100. Still 15 more years to go. 85 over. 85 years are completed. And widened in 2013. Just see the widened. The road length is nothing but road length 2,462 meters and followed by the rail length 7,009 meters. Very high, very long. So here you can see how they are actually monitoring with the help of 800 static and dynamic one. This one actually, this particular bridge is actually the very beautiful one. Actually, this particular bridge is connecting Asia as well as the on other part. Okay, first we'll go through what. One second. Okay, the Fatih Sultan Mehmed Bridge actually is in Turkey, also known as the second Bosphorus Bridge. They are trying to keep some peculiar name. It has been monitored using an innovative wireless sensor network. What exactly are trying to work with that? Our electromagnetic systems with the normal traffic conditions.
Excuse me, sir. Hello, sir.
Yeah, please. Yes, please.
Your PPT is not showing, sir. Not visible.
Oh, 1 second, sir. Then. I don't know, sir. So then shall I stop my video, sir? Maybe due to the signal strength. Okay. Is it okay, sir?
Slide is not so.
1 second. 1 second. One second. One second. I'll start my video. Okay. I'll just, yeah, maybe due to the signal strength, maybe. One second. So whether it is visible now, sir?
Visible, sir.
Now it is.
It is coming, sir.
Okay. Sir, I have switched off my video. Okay, sir. Is it okay?
Yes, sir, it is visible.
Okay, fine. I have switched off my video. The reason maybe is due to the signal strength. That is the problem.
No problem.
Okay, once again, I'll repeat this one. I'm sure actually the previous slide you have actually seen this one. This one is actually, you could see that, right? Previously we have discussed. Yeah, fine. Okay. This particular one in Turkey, right? Fine. Yeah. This one actually in Hong Kong. Hong Kong actually they have the Shingma. Sir, Venkatachalam sir, is it audible, sir? Hello?
Yes, sir. It is audible,
Fine.
sir.
Okay, thank you. Because I'm not getting any noises. That's right. Okay. This particular bridge actually named the two different bridges actually. Shingma, Tingha, Kopshi, okay, moon bridges. So like that they have the bridges in the Hong Kong, right? Approximately 900 sensors. Actually, Hong Kong, China, particularly the South Korean countries, but the Japanese, right? They are actually working a lot on the monitoring health system. The main problem they are facing the earthquake issues. Threat. The earthquake threat is actually they have all the time. Particularly Taiwan, right? They are trying to keep the maximum number of sensors. Because they every week, right? Taiwan in general, recently my friend visited. When actually getting your earthquake alert, obviously the mobile phone they will be getting the message. That's all. Fine. Right. Just see the beauty. Then obviously you'll be getting immediately. You can do all the precautionary things, right? You can able to stay out, or you can move to the safest zone. Right. The same thing here, right? That's why they are trying to keep maximum number of sensors. Around 900 sensors are monitoring, particularly the electromagnetic sensors, wireless sensor systems. Here we have the other two. The first one we have COP3 as well as the moon, right? The other two bridges. Shingma, the length is around 1,377 meters. Tingha, length around 1,177 meters. This is a very olden bridge, right? How they are monitoring it. One second, sir. One second. Okay. Yeah. This particular bridge, I like to say that, okay, this particular bridge, already we have discussed, right? The Turkey bridge. It's actually, this particular bridge is connecting Asia. This particular bridge only connecting the Asia as well as the Europe. Asia as well as the Europe. Okay, this particular bridge. It's the beautiful one. Okay. The next one, the bridge actually New Asta Railway Bridge. Actually, the old one as well as the new bridge you can see at a time. The same figure itself, you can be able to see the old one as well as the new bridge. The Stockholm. New Asta Railway Bridge, right, in the Stockholm was built in 2000 to 2005. The total length of the New Asta Railway Bridge in 833 meter, and it is 19.5 meter wide. The distance, the width. The distance between the new and the old bridge is 45 meters. They are trying to keep both the distance is nothing but old as well as the new bridge. The new bridge is nothing but the steel structure. The old bridge.
Excuse me, sir.
Yes, please.
Again, the slide, it is not visible, sir.
It's not visible.
Yes, sir.
Still it is. Sir, what about others, sir? Is it visible or not, sir?
Slide is not coming, sir. Okay. Your audio is visible.
Okay. Now whether we are able to see that?
Once again present, sir.
Once again, sir.
Once again present now, sir.
Okay. 1 second. 1 second, sir. Maybe this may be due to the signal strength. Sir, whether you are able to see that?
Yes, sir. Yes, sir.
Okay. Okay. Thank you.
Yes.
Here, rainy season. That's why the signal changes with respect to time strength.
Okay, sir. No problem.
Thank you. Thank you. Thank you. A new Asta bridge here you can see, right? The two bridges at a time you can see in the picture. In the picture, on a steel rod bridge is actually the newly constructed one. Old one is actually the concrete structure. In the concrete structure, actually the new one actually built is a railway bridge is a 833-meter long, 19.5-meter wide. Okay, let it be. The distance between the two bridges, new as well as old one, is actually 45 meters. SHMS actually on a structural health monitoring was installed on the bridge due to the unique design. Okay, so actually this particular one is a unique design. They are claiming that some slightly unique design. The monitoring is ongoing on the aims of the study are check both static and dynamic behavior of the structure. How they are monitoring it, here we'll be getting the idea. Here they have the old bridge, they have specified A, B, C, D, E. Okay, here this particular portion will be monitored. That's all. This is what they are classifying the node. Maybe, for example, internally, in between A and B, they will be classifying many sub nodes will be there. Sub node, okay, maybe 100 or 100 plus nodes will be there. So each and every point will be measured. That is the idea. Here they will be performing everything. The concern load testing for such related with the stress and strain, they will be measuring it. Okay, just almost we are on 5 to 10 minutes. I'll be finishing it. Inspection of fatigue cracks. Okay, the other one. How to do it? Normally, we used to conduct this one by using the ultrasonic testing. The ultrasonic interrogation of components for the detection and sizing of defects has advantages over the other technique in that surface as well as the subsurface defect. This is particularly after detecting. It's very simple. Try to understand. Initially, we have to use the wireless sensor network to understand where exactly the crack. Okay, after identifying the crack, the disaster management team or the recovery team will be coming. They know that what exactly the position, location. They know that after that we need such systems. Okay, after that we need the ultrasonic testing. Why we need ultrasonic testing? Without damaging the structure, right? We have to understand. Maybe the laser based one, or maybe for example this one ultrasonic, otherwise radar based one. Our job is to, without disturbing or without damaging this one, we have to understand that one. Then we'll be giving the input, what exactly the depth, what exactly the water content inside, and everything we will be getting the data will be given to the civil expert, the structural expert. Then structural expert, they will be having some on a protocol, they'll be having some on a procedure, right, to save the pillar or save the structure. That's all. This is what. Without damaging the right overall structure, they will be saving the structure. Then experimental configuration of our ultrasonic measurement is such that the fatigue crack is eliminated by a longitudinal wave. Just this is what they are trying to do, that by a longitudinal wave incident perpendicular to the crack face and focused in the plane of the crack. Okay. The longitudinal wave is partially transmitted by the closure zone and picked up by the another focused receiver transducer. Okay, what exactly they are trying to do? That they'll be changing the angle, right? Obviously, then actually on a light, actually the signal is ultrasonic signal is hitting on the surface, right? One first angle they'll be checking it and different angle, then put together all the foot on a different angle, they'll be adding together. Then easy to understand breadth and width of the damage on a micro cracks, right, from the top to the bottom. That's all they're aiming. We have to change the angle, right? Then only we'll be getting the multi-dimensional on a picture. By changing the angular orientation of this receiver, one can monitor the frequency, spatial, angular dependence of the crack. Our ultimate aim to get the exact 360 degree of the crack depth as well as the picture. That's all. The eddy current. Here the eddy current can be used for inspection of fatigue crack. Okay. The last one, seismic one. Okay, this one. I'll be finishing by using this one, particularly the civil engineering idea. Seismic damage identification, a distributed fiber optic monitoring methodology based on the optic time OTDR, optic time domain reflectometry, what we used to say OTDR technology is developed for seismic damage identification of steel structure. Okay, sensing the local deformation of the structure for the epoxy modulates the signal changes within the optical fiber response to the damaged state of the structure. Where exactly we need this one means simple. Under the maybe the sea, right? Particularly where they have connected the Turkey, right? This thing that most of the bridges actually built on the river, right? Most of the bridges today nowadays, most of the bridges actually built with the help of steel structure. The reason is nothing but the building time is very minimum. Same time, easy to replace the things. easily. For wherever exactly the portion is damaged after something, right, the particular part will be removed, not like the concrete structure. The concrete structure main problem will take, the construction time is very high, because it's required. When the time is increasing, obviously the life of the building will be, survival time will be high. So obviously that is a problem. So here, under the, for example, the sea level, water level, right, there is a structure. So how to monitor it? By using this one, it's possible. Yeah, exactly, identifying the location is possible. Damage can be identified by the optical sensors. Maximum, this is their aim. Maximum local deformation can be recorded. Where exactly the local deformation can be recorded by the sensing system. Moreover, the damage evaluation can also be identified. This particular things are actually seismic damage identification. The previous one, inspection of fatigue cracks. So actually, after identifying, using the wireless sensor system. Initially, wireless sensor systems only used, for example, to identify where exactly the problem exists. Once identified the location, after that only we need this particular ultrasonic sensors, piezoelectric sensors, as well as this particular fiber optic OTDR system. OTD, with the help of OTDR, where exactly the fiber optic, right, easy to identify the local deformation. Okay. After that, what we have to do? IoT platform for SHM. Nowadays we have IoT platform for structural health monitoring systems are there. Okay. So obviously Raspberry Pi or this will be connected to the cloud, right? Fine. Analog to piezoelectric. Here we have taken the few sensors, right? Piezoelectric sensors 1, 2, 3, 4 or something. Analog to digital conversion. Then buffer will be there. It will be saved in the data. This is a way normally we are performing. In artificial intelligence also involved in that. So there we have the opportunity here, particularly in coming future. I am sure the coming future, government of India, as a majority of this particular monitoring systems will be outsourced, no doubt. Particularly Indian Railways, the maximum opportunity the startup companies will get. Indian Railways and each and every state government. Almost Goa state government has already started. The thing is actually almost all the union government, the union territories already started this work. So here actually the job opportunities are high. So what we have to do, we should know that we have to undergo what exactly the structural health monitoring things, how to do that. So if you are specialized only for the bridges, then focus on bridges. But today in India, focusing on bridge is not at all the advisable one. That you will be getting the project, but higher project only it is possible. Mostly government of India will be going with the abroad company. They will be coming and quoting for the very minimum price, right? Hard to get the project. But getting the project for to monitor the road or to monitor the maybe the hill station landsliding or to monitor the on a bridges, normal one, the small level structures, right, the dams and all the thing, easy to get it. How to get it? Obviously the higher companies will be quoting the price. After that, easy to get the subcontract. So if you have the startup company, easy to quote the price, right, easy to get it. Being electronics and communication engineer or electrical and electronics engineer, easy to get it. This is what normally the background of the IoT platform, right? These are the things we know, that how to interface the things, right? From the sensors, DAQ, digital acquisition systems will be there, followed by the, will be having, it will be connected to the cloud. Fine, the cloud, the data, okay, how we are actually retrieving the data, the results will be on the internet server. If you have the artificial intelligence, easy to pick the data, wherever the data is actually on displaying very fishy. Okay, whenever you actually are getting the data very fishy or controversial, right? That time easy to pick the data separately. So the engineer will be getting the data. System itself, if you are already advised that if this is a data, this is a threshold, whenever the threshold level, whenever the data is actually less than the threshold or above the threshold, what do you have to do? The system will be doing it everything. Okay. Overall, my aim is very simple thing. I have attempted for the thing, deliver the things actually, the possibility where we have the opportunity for the electronics and communication engineers, for the civil engineering or mechanical engineering perspective. There, so our ultimate aim is nothing but we have to develop a startup company along with some group of friends, right? We have to start up a company. Then we have to focus it. Today, the Indian Railways, right? Repeating again, Indian Railways, each and every kilometer is actually monitored by the human beings, the employees, their employees throughout India. Every day, their job is actually with the help of the trolley van, right? They have the checking in the trolley van will be there throughout each and every kilometer. They have to check, they have to update it into their server, whether it is actually perfect or not. Because if it is actually not perfect, mean the next problem is nothing but derail. That's all. Somewhere actually due to the slight alignment, the derail problems will be there. Derailing, such problem will be there. So to avoid such issues, right, they are spending a lot. Government, the Indian Railways spending a lot to avoid the accidents. So if you are able to get the outsourcing, right, if you have the technology, right, no need to do involve this many too many manpower there. right? With the help of digital technology, right? Our job is to check whether the sensor is working or not. That's all our job. Each and every node. It's easy to do that. Even in Indian railways today, trolley previous days, node by node, the manpower checking is there. Nowadays, actually, on the trolley van itself, they have the sensor. What exactly the distance and everything that keeps on angle and everything is measuring. They have the sensor. The basic level of sensor nowadays actually they have installed in that on checking the trolley van. Okay, overall the summary I like to finish it now. For the safety of a structure, with the strength and integrity, the sensors are used to provide the real-time information of the structure. Sensors can be used to study the dynamic measurement in the structural elements, bridge, damage, tank, any kind of tank. Just think that maybe in the on a chemical tanks will be the right. If any slight damage, right, leads to the lot of damages. So, just particularly the Dow chemicals in the Bhopal. You see that the disaster, Bhopal disaster, still how to, for example, give a solution to the neighbors who actually living in the Bhopal, the surrounding nearby the particular town, right? How to give a solution for them. That is a problem. So if you have the technology, easy to prevent the damage. Because of use of these sensors, we are able to get real-time information of the structure, and further decisions can be made with available information regarding structural strength, and life can be extended. Life of the system will be extended. The development and the use of these sensors are to be encouraged for the safety of the structures and life. Hereafter is very simple thing towards the humanity, right? We have to try to, when the development is increasing, obviously we have to think in the angle of humanity. How to get a humanity? Very simple thing. We have to increase the safety. How to improve the safety? Some precautionary things. All the things we have to monitor the system. That's all. This is what we have to do it. So anyhow, I'm sure and thank you. I'm finishing it here. If you have any questions, I'm really happy to discuss in detail about that.
Thank you, sir.
Question.
The session is very informative for us. We gathered many information about the sensing technology. Now this is the time for the question session. Dear participants, if you have any queries, you can ask.
You can tell the participants, anybody have questions can directly ask. Participants, if you have any questions, you can directly ask. You can unmute your mic and you can ask the questions. You have one question here.
My question, sir. Good morning. Good morning.
Good morning.
Good. My question.
Yeah, good morning, sir.
Hello. Good morning.
Hello.
Good
Yes,
morning.
sir, please.
Hello. Good morning.
Hello. Sir, good morning, sir. Please, sir.
My question.
Hello.
My question.
Yeah, you can proceed with the question.
Yeah, my
Yes.
question. Is the radar type of sensor used for that bridge? Hello.
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 Hello, sir. Please
Good
tell me,
morning.
sir. Good morning, sir.
Good morning. Good morning. Is the radar type of sensor used for the bridge monitoring? Hello.
Hello.
Good morning.
Sir, please tell me the question, sir. I am ready to answer
Good
it,
morning.
sir.
So, Tunji
Good
John,
morning.
we are able to hear you. You can directly proceed with your question.
Good morning. Good morning. Is the radar type of sensor used for the bridge monitoring?
Is it radar type of sensor?
Is the radar type of sensor used for bridge monitoring? You know.
Okay, sir.
I will ask
Hello?
a question on your. Is it a radar type of sensor for bridge
It's
monitoring?
radar type of sensor.
Sir, anyone, sir, question, sir, please. Anyone, please ask.
Hello?
Someone
Actually,
to.
why is it
Hello?
not audible?
Good
I am
morning.
repeating the question.
So please, sir.
Yeah, actually, is
Good
it a
morning.
radar type of
Should I
sensor
type it
for
on
the
the chat bar?
Hello.
Hello?
Sir, on
Hello?
other, sir, on the
I'll
faculty.
be sharing this on the, sir, I'll be sharing this on chat screen. Is it a radar type of sensor for bridge monitoring?
Radar type of sensor, actually bridge monitoring, we are actually, yes, we are wireless sensors only, we are working on that. But
Yes.
in radar type of sensors means
This is my question on the chat bar.
we are working on ultrasonic sensors to monitor the fatigue cracks. But exactly to monitor the radar means you can use a ground penetrating
repeat
radar,
it.
you can use it. Ground
Is the
penetrating radar sensor.
Yes. This is used for bridge monitoring alone.
Yeah, sir, I have next question. Does the sensor in Rio Antonio Bridge stay within the lifespan of the bridge?
Not inside actually, but the thing is actually if you're trying to keep inside the particular on stray cables means hard to know the motion or something displacement. So we have to try to keep away, just a kilometer away or something. Then only we can able to see the bending, deformation, everything. Why we have to monitor the exactly the stray cable means the stray cable only the identification. Is there any bending? Mean obviously you can change in the on a deformation in the cable. Cable is actually the bendable one. Why they are trying to keep the bendable one means the reason is nothing but under one is a river, right? We are trying to keep it on the silver, the stay on a steel on a rods or something, right? The steel rod is acceptable 100% is nothing but the vibration acceptable one. Whatever the vibration, it will be delivering it to the max the load at the load, right? So the stray cable is nothing but bendable. Whatever the maximum up to some threshold level, it is acceptable one. After that, still it is actually bending in with the help of sensor where we have to keep a kilometer long, right? With the reason already I told, majority of these particular bridges are kept exactly at the river or maybe on the top of the ocean, right? So it's hard to keep exactly nearby. So we'll be trying to maintain a kilometer away. So easy to see the whether how much it is actually the deformation occurs on the stray cables. Away. It's not exactly inside, it's away. Even you can easy to create a strain or stress or strain cages inside the cable. That is also possible. Whenever actually the stress or strain is exceeding the limit, that time that is also possible. Mostly the mechanical sensors will be kept inside the bridge on the cable on the load or something. Our electronic sensors will be keeping a kilometer away or something. Wireless sensors will be keep it exactly away from the bridge. I'm not sure whether I have answered what exactly I've asked. Yes, a lot of noises are coming. That is a problem, maybe.
Any other questions? So, any other questions? Participants, do you have any other questions?
My question is on the chat bar.
Any other questions?
All is clear, sir. Thanks, sir. Please provide me.
WhatsApp, Google. Okay, sir.
Finish.
First, call discussion. Hello, sir.
Uh, Madam. Hello, sir.
Please tell me,
Hello.
sir. Hello.
Okay, sir. Shall we come to vote of thanks, sir?
Oh, sure, sir.
Okay.
Now I request Mrs. Gauravi Shetty, Assistant Professor, Department of ECE, to give vote of thanks.
Good morning to all. I thank all the people associated to this webinar for providing me an opportunity to propose vote of thanks. First and foremost, I thank our speaker, Dr. Anand S., Associate Professor, Department of Communication Engineering, VIT Vellore, for making time and sharing his knowledge. Thank you, sir. It was very enriching experience. Now, I would like to thank our management, our principals, our vice principals for their unflinching support for conduction of this program. My heartfelt thanks to the HOD and faculty of Department of Electronics and Communication Engineering, Navodaya Institute of Technology, Raichur, for their valuable efforts for arranging this webinar. Last but not least, I would like to thank all the participants from various engineering colleges for participating enthusiastically and making this event a resounding success. Thank you one and all.
Hello, sir.
Hello, sir.
Thank you, sir. Thank you for your valuable information to us, giving valuable information to us. Sir, feedback.
The feedback link will be provided in the chat section, as well as we will be sharing the feedback link in the WhatsApp group. Okay.
Okay, then. Thank you all. Okay.
Thank you. Thanks for your informative lecture.
Okay. Have a great day. Yeah. Okay, then. Thank you all. Bye. Take care.
Thank you very much. This is very educative event. Thanks. What's next? fi fóònù ẹ̀ sí orí ẹ̀ lọ́jà lòkù bí àwọn olùfẹ́ torí pé ẹja lòkù olùfẹ́. Owó ní sí méjì ló wà mí. Sínú kejì lọ.
Báńdé pa fóònù.
Kejì lọ ìṣàlá bẹ̀rẹ̀. Ojú dànù. Fẹ́ pàdé ní ìjẹ́ náà. Máa fi ní ọba ṣe fẹ́ wọ́n ọ̀gá àpò àmà sí i. Èso ló fẹ́ bá rẹ́jísà. Pẹ̀lú kọ́ ló ti jábọ́ ẹ̀gbọ́n bó ṣe ń ṣe. Ilé ìyàbẹ̀ ti ọba wọn sí mẹ́ta tó bá ń bọ̀. Ilé ọlọ́lẹ̀ máa fẹ́ wà ọ́ àti pé ẹ̀sìn sí mọ́tò. Ó lè tún bá jù lọ́gbọ̀ ìgbà. Seri ayaba. Amen. Wherever we sin against you, have mercy on us in the name of Jesus. Amen. As you go out this morning, go with us in the name of Jesus. Uphold us and secure our lives in the name of Jesus. Daddy, protect us, Lord, in the name of Jesus. Amen. When we come back, let us have to glorify your holy name. Amen. In Jesus' almighty name. Amen. 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 In Jesus' name. Hallelujah. Hallelujah. Hallelujah.